Chemistry, this is the answers video for the day 27-28 molar mass assignment. It's a long assignment. I've given you a lot of extra time on this. I would like this turned in absolutely by Tuesday, March the 15th. So that's a full week after the original due date. Okay, I will start marking assignments down a bit if they're not turned in by the due date. So we're going to change this to March 15th. Okay, that gives you this weekend plus Monday, and we've done most of these in class anyway. Okay, so let's go ahead and proceed with this. So I gave these answers, we did these answers, the class did these answers, so let's go ahead and do this, the pre-assignment. So what is Avogadro's number? And I want you to write complete sentence answers. That way it helps you to retain the information, or if you go back and study it later, it will allow you to put the answer in context. It's not just a number written down or just a word, a single word, okay? So here we go. So what's Avogadro's number? Avogadro's number is 6.022 times 10 to the 23rd. Could be of anything. Atoms, molecules, pizzas, dogs. It doesn't matter. It's just a number like a dozen is 12. What is a mole? A mole is 6.022 times 10 to the 23rd. Mole is the word we use in everyday conversation. You almost never hear the term Avogadro's number again. What is atomic mass? Atomic mass is the mass of one atom or one molecule. Okay, that's it. So oxygen, for example, look at your periodic table. And you should have your periodic table out right now. Or if you don't have one, you didn't bring your packet home, or you don't have one at home, just pull it up on a background tab on your computer. Okay, but have one available, or in almost any book that has to do with chemistry. Your chemistry books are at school, but just bring it up on a background tab on your computer. Okay, so atomic mass is the mass of one atom or molecule of a substance. So oxygen has an atomic mass of 16 atomic mass units for a single oxygen atom. What is molar mass? Molar mass is the mass of 1 mole of atoms or molecules. So if you have 1 mole, that's 6.022 times 10 to the 23rd oxygen atoms, and they have an atomic mass of 16, then AMU, then the molar mass is 16 grams. What is the significance of 6.022 times 10 to the 23rd as the value for 1 mole? So we just mentioned that. 6.022 times 10 to the 23rd converts the atomic mass in atomic mass units to the same number of grams of the substance. So for example, 16 atomic mass units of oxygen becomes 16 grams of oxygen if you have 6.022 times 10 to the 23rd molecules, or atoms rather, of oxygen. Okay. What is the mass of 1 proton or 1 neutron? This is not the official definition, but we don't really care about the official definition. This is the practical definition. 1 proton or 1 neutron has a mass of 1 atomic mass unit. So we're going to treat them as though they have exactly the same mass, and that mass is 1 atomic mass units. Therefore, if you know the number of protons or neutrons in an atom, you will know its atomic mass, because we don't count the electrons since they're very, very small and very light. What is the mass of 1 mole of protons or neutrons? So adjust my camera here a little. So you have 6.022 times 10 to the 23rd protons or neutrons. It's going to be 1, but 1 mole of protons or 1 mole of neutrons has a mass of 1 gram. So it converts it to grams, something that we have scales to weigh, that scales that are measured in grams, that are calibrated in grams. So that's the significance of the mole. If the atomic mass of 1 molecule of a substance is 78 atomic mass units, what is the molar mass? So 1 molecule equals 78 AMU, then the molar mass is 78 grams. So it's the same number, it's just the unit that you're measuring it in changes to one that we can actually use in the lab. Alright, moving on. Number 9, still part of the pre-assignment. It was, these answers were given out in class, so let's just go over all of them. I want you to identify each of these as either an element or a compound, and either a molecule or unit cell. Okay? So O2. O2 is an element because it only has 1 element in it. Okay? It is covalently bonded. That is, oxygen is a nonmetal, so it's a nonmetal. So that's covalently bonded. That makes it a molecule. KCl. So KCl has two elements, and if a substance has two or more elements, it is a compound. K is a metal, chlorine is a nonmetal. Metal-nonmetal forms ionic bonds. So it's an ionic bond. Metal, the potassium K. So that would make it a unit cell. Water, H2O. Non-metal and non-metal. Even though hydrogen is in the upper left-hand corner of the periodic table where the metals are, it is a non-metal. It's just an unusual location for it. It's the only non-metal like that. So this is non-metal, non-metal. So that's, well, first of all, it's two elements. That makes it a compound. Okay, covalent bond, it's a molecule. Covalent bonds are non-metal, non-metal bonds, two strong guys. They share electrons because they can't take the electrons away from the other guy. So they decide to share electrons. They form molecules, independent structures that can move around independently. Like when you boil water, the steam molecules go off in different directions. Okay, NO. At this point, I'll just write the answer, compound. Two or more elements. And N, non-metal, non-metal. So again, covalent bond. Finally, non-metal, non-metal for carbon dioxide. And there's two elements, two or more elements, could be more than two. All right, and that takes care of that. All right, now we're going to compute the atomic and molar masses for a number of different substances here. And the two are computed exactly the same way. That's part of the point of this exercise. But to show you, the only difference is atomic mass is in atomic mass units. It's of a single molecule of these substances. And molar mass is of 1 mole, 6.022 times 10 to the 23rd molecules of these substances. Okay, so let's get started. The way you do this, just do it in a very organized fashion. You have carbon, oxygen, you have 1 carbon. If there's no subscript, it means there's 1. And you have 2 oxygen atoms. Okay, so now you bring in a periodic table. You have to have a periodic table. Again, pull one up if you're at home and don't have your packet with you. So carbon has an atomic mass of 12.01. So you're going to multiply 1 atom times 12.01 atomic mass units, or atomic mass units per atom, and that equals 12.01. Now we look over at oxygen. Oxygen is exactly 16, so 16.00, so you have 2 of those. You multiply that, that's 32. And now, ideally I should have lined this up a little better, but you add those together and you get the is 44.01 AMU. And molar mass, same number, grams. And that's how you do all of these. Okay, so I'm going to do about five or six of them here and leave the rest for you. We'll go down and do hydrogen. Do this in any order, but it's 20 hydrogen. And finally oxygen, there's 1. You don't normally write the subscript, but I did there. Carbon, again, you got to go to your periodic table. Pretty soon you'll have these memorized if you do your assignments regularly. You don't have to memorize them, you just will. Is 12.01. Okay. Equals, and I won't put a unit here because it's going to be different down at the bottom. Hydrogen is 20 times 1.01, and that's 20.20. Finally, oxygen. Now you add these up. And made a little error here, so let's correct that. That should be 0.10. Okay, and that gives us 156.40. So the molar mass, there's not a lot of room to write it. You can write it over here. Atomic mass, molar mass is in grams. Okay, that's how you do that. Let's keep going. Go to your periodic table for 12.01. Hydrogen, 4. Go to your periodic table, it's 1.01. And oxygen is 2. And periodic table says that's 16. When you add these up, you get 32, 42, 52, 56, 60. Okay, so atomic mass and molar mass, I'll write over here. That's in grams. Okay, the only difference. Same number, different unit of measure. Okay, I'm going to work through the rest kind of quickly here, and you can just go ahead. I'll pause at the end of each one, but I'll do them silently, and you try to do them first, okay? It's not a copying exercise. Here we go. Okay, there we go. So we get 156.16 AMU if it's a single molecule. If it's 6.02 times 10 to the 23rd molecules, it's 156.16 grams. All right, let's keep going. Just abbreviate atomic mass like this. Molar mass, that is the abbreviation for molar mass. Okay, and that's your answer for that. Table sugar, this is a big one. Should not write the subscripts there. Okay, so for our extensions here, 12 times 12.01 right there, 22 times 1.01 there, 11 times 16 there, they all add up to that. So atomic mass and molar mass in grams. All right, we'll continue. This will be the last one that we'll do. These three are left for you to do entirely on your own. I will do them in tutoring with you if you come to tutoring, okay? Okay, so that takes care of this for doing molar mass calculations. At a lot of points in this class, you'll be given a molar mass calculation if you need to use it, but you should know how to calculate them, and you might have to do it in some of the later problems. That takes care of that. Okay, so we're going to move on to page 3. So what we're going to do now is start answering some questions regarding atomic and molar masses of particular compounds. Water is already done for you in the instruction video. So I'm going to move past that. You can go to the instruction video to see the answers. The questions are exactly the same here. There's 8 questions all the way down to the bottom of the page there, and you can do those. So now we're going to move on to the next page, which will be page 4. Okay, so now we're going to fill out the table for carbon dioxide. Believe me, you don't have to do this for every problem you do for the rest of the class. We're trying to really start from the foundations and see how we get the numbers that we get here. But eventually you'll move right past this in later problems. Okay, so first we need to fill out the table. So what over in the left column it's asking us for in carbon dioxide, the element. So you have 2 elements, carbon and oxygen. And down in the bottom row is going to be the combined structure, which in this case is covalently bonded. It's a molecule. So now the second column is how many do you have? CO2, you have 1 carbon. you have 2 oxygen. Now they get put together to make 1 carbon dioxide molecule, not 3. You need 1 seat and 2 wheels to make 1 bicycle. You need 1 carbon and 2 oxygen to make 1 CO2 molecule. That's a single structure that combines those. Okay, so the atomic or molar mass, just like we did on the previous problem. And you can write that answer down. Here's 12.01. It's AMU. It's a single atom or molecule. Two atoms of oxygen. It's going to be 2 times 16, 32 atomic mass units. Now you do add these two numbers together to get the total mass of the carbon dioxide molecule. Okay, so now we're done with the atomic molecular scale. What's not very useful to us because we can't see them or weigh them. So now we're going to multiply everything over here by this number, 6.02, 2 times 10 to the 23rd. So it doesn't really matter what you call a mole. If you multiply this by a mole, you get a mole, so it's going to be 1. If you multiply 2 by a mole, you get 2 moles. And you multiply this by a mole, you get 1 mole. So that's not the magic of 6.02, 2 times 10 to the 23rd. The next column is, which is at this number, 12.01 simply transfers over to here. 12.01, but it changes to grams. 32, I'm going to leave off the zeros just to save space, is grams. You add them up, you get 44 grams, okay? Same number in this column as in this column. That's the magic of this number. Only that number will do that. Now, number of atoms or molecules, and I told you that you don't need to actually do the calculation. It's too many numbers. Just set up the equation. So if you have 1 mole, you have 1 times, and I don't really care if you write the 1 there, 6.022 times 10 to the 23rd. Okay, so just leave it like that. You don't have to write equals 6.02 times 10 to the 23rd. Now you have 2 moles, so that's 2 times 6.022 times 10 to the 23rd. And again, you don't need to multiply that out. It's too much information, too many numbers. And then 1 times a mole is 1 times 6.022 times 10 to the 23rd. Okay, so now we have our table filled out. So what's in this big red box is everything in terms of numbers of moles, molar mass, number of atoms that applies to this number right here, 1 mole of CO2. So if I want 2 moles of CO2, I need twice as much of this, twice as much of this, twice as much of this, twice as many of these, twice as many of these. You just multiply by 2. Okay? You need this many ingredients to bake 1 cake. If you want 2 cakes, you need twice this many ingredients. If you want 10 cakes, you need 10 times. That's all there is to this. It's really not that hard. I am going to be particular that you write out these complete sentences. I know it takes a little more time, but go ahead and do it, and it will give you context when you go back to study it, and it will stick in your mind better that you've written it out as a complete sentence. Okay, so let's go ahead and CO2. So how many CO2 molecules in 2.5 moles of CO2? So in 1 mole of CO2, there's 6.022 times 10 to the 23rd CO2 molecules. So in 2.5 moles, there's 2.5 times that number right there. So we're going to go ahead and write that. All right, so there are 2.5 times this number. You don't have to write the units of measure when you're doing the calculation, just when you get the final number. 1.5 times 10 to the 24th molecules of CO2 in 2.5 moles of CO2. So how did we get that? If you multiply 2.5 by 6.022, you get 15.055. All right, but in a scientific notation number, the coefficient should be a number between 1 and 9. So 15.05, we're going to move the decimal over to make it 1.5. That's a number between 1 and 9.99. So since you made that number smaller, you went from 15 to 1.5, you have to make the exponent bigger. You go from 23 to 24. So it's just that decimal adjustment we talked about when we were studying scientific notation. Then the way you write the units is the unit, and unfortunately there's no abbreviation for molecule, and you just write molecule even though it's plural, just write molecule, and then in parentheses the substance. So unit of measure and substance always. molecules CO2 in what they asked for, 2.5 mole, no E on the end of mole, of CO2. All right, so just kind of study that format of the problem, and we'll move on. How many grams in 3.2 moles of CO2? It really, to be more complete, should say how many grams of CO2 is 3.2 moles of CO2. Okay, so let's go ahead and write it. So in 1 mole of CO2, there's 44.01 grams. So if you want 3 moles of this, you need 3 times 44, or 3.2, rather 3.2 grams of CO2 there. So 3.2 in the problem, okay? Okay, so let's break this down. So again, you want 1 mole, you need this many grams. You want 3.2 moles, you need 3.2 times this many. You don't have to put the units of measure here, but put them definitely at the end of the final answer. So there are 3.2 times 44.01 equals 140.8. I'm just arbitrarily going to that many digits. I usually like to just go to one place after the decimal, even though significant figures says the answer should only be 2 significant figures. I'm not going to worry about significant figures here. So there's 140.8 grams of CO2 in 3.2 moles of CO2. All right, let's keep going. Going to have to move the paper back and forth here as we get down lower on the page. How many moles of oxygen in 4.7 moles of CO2? So you come up here. There's oxygen number moles. If you want 4.7 moles of CO2, then you're going to need 4.7 times this many moles of oxygen, which is what you need for 1 mole. So 4.7 times 2 is going to be that. Okay, there it is. It doesn't take that long to write the sentence. So there's 4.7 times 2 equals 9.4 moles of O2 and 4.7 moles CO2. You always need twice as many moles of oxygen as you want to produce moles of CO2, so 9.4 is twice as many moles as 4.7. All right, we'll keep going down here. How many grams of oxygen in 3.5 moles of CO2? We come back up. In 1 mole of CO2, you need 32 grams of oxygen. So if you want 3.5 moles, you're going to need 3.5 times this number right here. Okay, so again, if 1 mole, you need 32, so 3.5, you need 3.5 times 32. That gives you 112 grams of oxygen in 3.5 moles of CO2. How many carbon atoms in 2.7 moles of CO2? So in 1 mole of CO2, you need 1 mole of carbon. That's 6.022 times 10 to the 23rd. So if you want 2.7 moles of CO2, you need 2.7 carbon atoms to get you there. So we'll go ahead and do that. Okay, so that's how you would write that. And yes, I did say you don't need to do this. So this is optional to actually do that calculation. If you don't do this, though, you should put the units of measure after that. All you need to write is 2.7 times 6.022 times 10 to the 23rd atoms of carbon. You don't have to do that calculation, so I'm writing the word optional up here. Okay, in 2.7 moles of CO2. Again, 1 mole of CO2 is 1 mole, or 6.02 times 10 to the 23rd atoms of carbon, rather. So 2.7 moles of CO2 is going to be 2.7 times this number. All right, we'll keep going. Last one for this set. How many grams of carbon in 0.4 moles of CO2? So you don't always have to scale up. This one's going to be less. It's going to go down. You have less than 1 mole of CO2. So let's look at that. So you need 12.01 grams of carbon for 1 mole. So if you want 0.4 moles, you just multiply that by 0.4. Don't do any dividing here. 1 times 0.4 is 0.4 moles of CO2. So 0.4 times 12.01 grams of carbon. So we'll go ahead and write that out. Okay, so there we go. There's 0.4 times 12.01 grams of carbon in 0.4 moles of CO2. That takes care of that. Alright, I don't want my videos to go more than 30 minutes, so I'm going to wrap this one up. There will be a second video that shows the rest of the problems. It won't be as long as this one. One of the advantages of watching these answers videos is, first of all, if I make a mistake on the assignment, I can correct it. You'll see it corrected on the answers video. I try to do it in class as well, but if I don't, you'll see it on this video. And finally, the other advantage is you get some insight into technique. How do you solve this, okay? By listening to me explain it while you see it done, rather than me just giving you answers on a sheet of paper. So that takes care of that. We'll have the rest of the problems on the next video.